So I can get started from here. Get started. Did we complete this problem? We are done? Okay. This one? No, right? We'll get started. So is there any doubt from yesterday's class? Is there any concept that is not clear? Is everything fine? பின்னாடி ஒன்று what is that? பின்னாடி என்னமோ இருக்கு. ஒரே நிமிஷம் தான். இந்த ப்ராப்ளம் கரண்ட் பவர் கட் ஆகிட்டே இருக்கு. நான் எப்படி சால்வ் பண்ற பென் இல்லை என்கிட்ட. அந்த பென் கடை இதுக்குறா. Done. So what are the question state? Did you all see the question? So if the rate of change of current is 4 ampere per second, okay, it induces an EMF of 20 millivolt in a solenoid. What is the self-inductance? So what is the formula for it? L is equal to E divided by dI by dt. E is how much? 20 millivolt. So 20 millivolt nevoloda. How will you convert it to volt? So 20 into 10 power minus 3. So how much will you get? 0.002. So 0.02 divided by di by dt is 4. So 0.02 divided by 4 is how much? 0.02 divided by 4 is? So 0.005, or you can write it as 5 into 10 power minus 3 Henry, which will be 5 millihenry. Did you all get the answer? Got it? So 5 millihenry is the answer. Next. So the next question is, there is a 12-volt battery. Okay, this one you can't solve it. It is based on series parallel. Now try this. Listen to this question. There is an inductor of 5 Henry inductance. An inductor of 5, write it down. An inductor of 5 Henry inductance. So L is equal to 5 Henry. Carries a steady current of 2 ampere. Carries a steady current of 2 ampere. How can a 50 volt self-induced EMF be made to appear in the inductor? So you have an inductor of inductance 5 Henry and it carries a current of 2 ampere. So you want to generate a 50 volt self-induced EMF in it. How can you do that? என்ன கேக்குறாங்களா question நல்லா கேட்டுக்கூடும். Okay, guys, listen to this. Listen to this. What are they saying? They have an inductor of 5 Henry, right? And how much is the steady current that is flowing through it? 2 ampere. So what is expected? You need to find, you need to induce a 50 volt EMF in the device. Now tell me one thing, across an inductor, if you want to create a self-induced EMF, what are we supposed to do? I told you there is only one, see, there is only one thing in this chapter that you need to do. If EMF is to be induced, you need to change the flux. So if the flux has to be changed, what is flowing in this inductor? There is a current of 2 ampere that is flowing in the inductor. Correct? So if I want to change the flux in it, what should I do to that current? I should change it. Correct? Yesterday we discussed one thing, you remember? That key was open and the key was closed. So when the key was open, when you closed it, what happened? The current went from 0 to a steady state value, due to which you had some EMF induced in it. What is the name of that EMF? Self-induced EMF or back EMF. And we saw a second case. What was it? The key was self-inductance. So when the key was closed, right, you opened it. What happened? Current came from steady state value to 0. So in this case, there is already current flowing through it. So the switch is already closed. So if you want to induce EMF in it, what are you supposed to do? You have to open the switch. Right? What are you supposed to do? You need to open the switch. When you open the switch, what is going to happen? The current will fall from 2 ampere to 0 ampere in how much time? Then you calculate. So indirectly what they are asking is, you have to bring the current from 2 ampere to 0 ampere in this much time. That is what you need to mention. That's the answer. Then are you able to understand? Sure. Right. So calculate the time and tell me. What formula are you going to use? E is equal to L into di by dt. Use it. E kuduthirukka problem la 50 volt. L is given in the problem 5. di evlo. What should be the change in current? Initially current is 2. From 2, where should it fall? To 0. So change in current is 2. So how much time will it take? So on the 2 ampere recircuit, let's take the time to be 0. So from 2, it is falling down to 0. How much time is it going to take? That's what you need to calculate. Calculate and tell me. 0.2 seconds. I don't know, there is a lot of power cut today. Moon vertical touch. Yeah, this is a question. So I hope everybody could solve this. So E is equal to minus L into di divided by dt. You can ignore the minus sign. So 50 volt is equal to L into delta I is 2 and delta T is what you need to calculate. So this will cancel this 25 times. What happened? So it can be anything. No, final. So 2 to 0 is 2 only. I'm only taking the change. Minus a plus and see, don't, that's what I told you in this chapter. You should know where to use minus L into di by dt and where not to use it. As long as you don't know which point is positive and which point is negative, why are you concerned about negative or positive? What does the minus sign indicate? There is only one indication for this minus sign. It is Lenz's law, that's it. See, there are only two formulae in this chapter. What is it? E is equal to minus L into di by dt, and the minus sign is the significance of Lenz's law. Everything is derived based on that. இன்னொன்று வந்து magnetic flux. இது ரெண்டு தான் formula நம்ம யூஸ் பண்றது. கரெக்டா? So in this case, there is no necessity for me to use a minus sign. I can just take it as plus also. I can take only the magnitude. Because when they told it is 50 volt, right? I don't know which side is positive, which side is negative. Why should I be bothered about it? So my volt, this is 50. So 50 is equal to L 5, right? Divided by T, which implies T is equal to 5 divided by 25, which is 1 by 5, which is going to be 0.2 seconds. So you need, how you are supposed to report the answer is, you need to bring the value of steady state current from 2 ampere to 0.0 ampere in how much time? In 0.2 seconds. If you are able to do that, you will be able to generate this much voltage. That's the answer. I hope it is clear. Can you do this? So problem 6. What is the self-inductance of an air core solenoid which is 50 centimeter long and 2 centimeter radius? So remember, we derived self-inductance for a solenoid, right? But what kind of a solenoid is it? It is a long solenoid. But if you see, in this problem, they didn't mention it as long solenoid. They only called it as solenoid. But how will you make a decision whether you should apply the formula that we derived there or not? By looking at the values. Here, if you observe, the length is 25 times more compared to the radius. So what does a long solenoid mean? Long solenoid means the length is more compared to its thickness. So how are they related? They are length is 25 times more compared to its thickness or compared to its radius. Right. Hence, I can conclude that it is a long solenoid. I can use that formula. Does it make sense? Are you able to understand what I'm saying? Right? And it has 500 turns. So you know the formula, just look at it, derive it. Apply it and find the value. Check your notes. என்ன இது இந்த சம்மா you applied that formula mu naught n square a square. So listen, one thing I would suggest is you need not actually check your notes. If at all you forget, see, that is the reason we are learning the derivation, right? If at all you forget in the exam, you cannot check your notes, right? How will you directly solve or able to recollect it? L is equal to only 3 steps. What is it? L is equal to n times phi divided by I. You remember this? So length, the inductance is the total flux divided by the amount of current flowing. So how do you write the flux as? Flux is equal to BA cos theta. So always theta is going to be 0. That you can remember. So BA divided by I. But what is the value of B? Mu naught into n into I. And you have an area here divided by I. Cancel these two. So this is going to be the formula. Mu naught n into mu naught small n into A. Makes sense? So mu naught into capital N by L into A is going to be the value of inductance. So they told air core, no. So when they say it is air core, you should take only mu naught because that is the permeability of air medium. So what is the value of mu naught? It is 4 pi into 10 power minus 7 into what is the value of capital N? It is going to be 500. What is going to be the length? It is going to be 50 centimeter. 50 into 10 power minus 2. What is going to be the area? Pi r square. So it is pi into r square, which is going to be 4 into 10 power minus 4. So 50 will cancel this 100 10 times. Sorry? Yes, square. Oh, sorry. N irukla. Sorry. I'm sorry. Correct. I'm sorry. There is a capital N here. I saw it's my mistake. There is a capital N. So here you will have N. N into N is going to be N square. So N square means it is going to be 500 square. So this 50 is going to be 50 only. So see what you can do. 4 pi into 4 pi is going to be 16 pi square into 10 power minus 7 into 500 square is going to be 25,000. So 25. N square மட்டும். Capital N மட்டும் தான் square. இல்லடா. Here you have capital N. Small n is equal to capital N by L. So what is getting multiplied is only capital N. So 16 pi square into 10 power minus 7 into what is 500 square? It is 25 into 10 power 4 divided by 50 into 10 power minus 2. Right? 10 power minus 7 into 10 power minus 4 is going to be 10 power minus 11. Am I clear? So 50 will get cancelled 2 times. So 2 will cancel the 16 8 times. So 8 pi square into 10 power minus 11 into, so 10 power minus 7 into 10 power 2. It is going to be 10 power minus 5 Henry. Got it? So 8 pi square into 10 power minus 5 Henry. I'm not sure how that. Because pi square is how much? 9 point something. 9 into 8 will be 72. So 7 point something or no. That is what that 7.8. Yeah. Shall we proceed to the next one? Doubt. Pen when. All right. Shall I proceed? Do this. An air-cooled solenoid with a length of 30 centimeter and area of cross-section 25 centimeter square has a number of turns 500 and carries a current of 2.5 ampere. The current is suddenly switched off in a brief time of 10 power minus 3 seconds. How much is the average back EMF induced across the ends of the open switch in the circuit? So take down the data. So it is an air-cooled solenoid and it has a length of 30 centimeter and the area of cross section is 25 centimeter square. And the number of turns is going to be 500 and it carries a current of how much ampere? It carries a current of 2.5 ampere. The current is suddenly switched off and in a brief time of how much value? 10 power minus 3 second is going to be 1 millisecond. In 1 millisecond, what is happening? There is an EMF that is getting induced. You need to calculate what is the value of it. So how will you do it? So what is the value of capital L? Just now we saw mu naught n square A divided by L into di by dt is how much? 2.5 divided by 10 power minus 3 and this is going to be the EMF induced. So it's a combination of finding this and this. I hope it makes sense. Right? What is the value of mu naught? It is 4 pi into 10 power minus 7 into n square is 500 square is 25 into 10 power 4. Right? Into A is how much? 25 centimeter square. So 25 into 10 power minus 4. The whole divided by L is how much? 30 into 10 power minus 2 into di by dt is 2.5 into 10 power 3. That is 5 by 2 into 10 power 3. Right? So 10 power minus 4 and 10 power 4 will get cancelled. So 25 will go 5 times, this will go 6 times, this will go 2 times, this will go 3 times, and 2 and 2 will get cancelled. 5 into 25 is going to be 75, 75 pi into, see, actually it is 25 into 25, you can write it as 625. So 625 pi, right, 625 pi into 10 power minus 4 into 10 power 2. The whole divided by 3. Right, the whole divided by 3, these many volts. So it's going to be 625 into 5 by 3 multiplied with 10 power minus 2. Clear with this? So had it been 624, right? 624, when you divide it with 3, what are you going to get? 624 by 3 is how much? Is it divisible by 3? Yes, you will get 308. Sorry, 208. Should be 208 pi into 10 power minus 2. And the value. So you took it as 22 by 7 then? So 21. So or else you can do this 22 by 7 means இது வந்து 208 னு எடுத்துக்கலாம். So 208 by 7 is how much? அப்படி கூட பண்ணலாம். Into 22. Okay. That calculation part I'm leaving it to you. Okay. 1 minute. Now we'll do some problems based on mutual inductance. So try this. What is the mutual inductance of pair of coils if the current change of 6 ampere in one coil causes the flux in the second coil of 2000 turns to change by 12 into 10 power minus 4 per turn? Don't look at it like a formula. What does mutual inductance state? So how will you derive that value of capital M? What was the first expression we wrote? Flux associated with the second coil is directly proportional to the current flowing in the first coil, right? So they've clearly mentioned what is the mutual inductance of pair of coils if a current change of 6 ampere in one coil causes the flux in the second coil to change by this value. So what is the flux in the second coil? Total flux in the second coil is 2000 into 12 into 10 power minus 4. See, 12 into 10 power minus 4 is for one turn. 2000 turns are there multiplied with 2000. This should be equal to capital M into what is the change in current taking place? 6. So 6 will cancel this 12 two times. So it should be 4000 into 10 power minus 4 is equal to capital M. So capital M should be equal to 0.4 Henry. Am I right? Did you understand? So it should be 0.4 Henry. But what will be the math? See, for exam purpose, you need to write the mathematical equation, right? How will you write it? N2 is equal to M21 times I1. So once you recollect this concept, N2 will be equal to M21 times I1. This is what you need to write. Am I clear with this? So from there, you will derive the formula. Next. Actually, it is an EMF. An EMF of 0.5 volt is developed in the secondary coil when the current in the primary coil changes from 5 to 2 ampere in 300 milliseconds. Calculate the mutual inductance. So what is the relation between EMF, mutual inductance, and change in current? See, we remember this, no? N2 is equal to M21 times I1. Am I right with this? So what will you do? Then you differentiate on both the sides. When you differentiate on both the sides, what are you going to get? So if I differentiate this with respect to time, N2 into d2 divided by dt is equal to M21 into di1 divided by dt. So what is this? This is EMF. So EMF is equal to M21 into di1 divided by dt. What is the EMF? Tell me. Half volt. So half is equal to M21 into what is delta I? 5 to 2 means it is 3 divided by, it is taking place in 300 milliseconds. 300 milliseconds is 0.3 seconds. So 0.3. 0.3 will cancel this 3 10 times. So M21 is equal to 1 by 20. 1 by 20 means 0.05 Henry. Am I right? So 1 by 2 is 0.5. 1 by 20 is 0.05. So 0.05 Henry. I hope you're clear with the logic. Conceptual puriyadilla. Yeah. Or you can write it as 50 millihenry. This change 0.5 to 2. அதுதான் தேவையில்லை. Change it because you are only concerned about magnitude. You can take the difference in this case. Difference is 5 to 2. It's not 0.5 to 2, it is 5 to 2. 5.0 to 2. Difference is 3. Shall I proceed? So we'll do one more problem based on this. Actually, the printing copy பண்றப்ப தப்பாயிடுச்சு. If வேலை ஏதோ தப்பா இருக்கு. So இந்த problem பண்ண. So we'll do one last problem and then we'll go to the next two theoretical topics. We'll finish that. Okay. Over a solenoid of 50 centimeter length and 2 centimeter radius and having 500 turns is wound another coil of 50 turns near the center. Calculate the mutual inductance of the two coils. So what is the length of the first solenoid? Over a solenoid of length 50 centimeter length and 2 centimeter radius and having 500 turns is wound another. See, the flux induced in the second coil is equal to mutual inductance of 2 with respect to 1 into I1. Am I right? Right. So what is N2 into phi2? So N2 into, can I write this as P2 into, can I write it as A1 into cos theta, the whole divided by I1 is equal to M21. So this implies, okay. So I'm not going with the formula. I'm just writing this. So what is the value of N2? 50. So 50 into, what is the value of B2? Sorry, it is not B2, it is B1A1. Yeah, it is B1A1. It is mu naught N1 I1 into A1, the whole divided by I1. I1 and I1 will get cancelled. So this implies, so let me leave it as it is, N2 itself. Now I'll substitute the value. So 50 into mu naught is how much? 4 pi into 10 power minus. Yeah. Into what is the value of N1? Small n1 is equal to 50 divided by 2. So 50 by 2 is going to be 25. 500, oh sorry, number of turns per unit. No, 500 divided by 2. It is going to be 250. Yeah, 50. Oh, length. Sorry. Yeah, radius. Yeah, sorry. My mistake. So it is 500 divided by 50, which is going to be 10 itself. So it's going to be 10 into, what is the value of A1? It is pi into r square, which is going to be 4 into 10 power minus 4, the whole divided by, there is nothing, no? That's it. So how much will be the answer? You calculate it. So this will be 50 into 10 is going to be 500. 500 into 4 is going to be 2000. 2000 into 4 is going to be either per centimeter. So 10 divided by 10 power minus 2. Sorry, one correction. Listen. It is 500 turns, but everything is in terms of SI unit. So 500 divided by 50 போட்டுருக்கோம்ல. 50 into 10 power minus 2 is what you need to put. It will be 1000. Okay. So come again. 50 into 4, 2000. 2000 into 10. Sorry, 50 into 4, 200. 200 into 10, 2000. 2000 into 4, 8000. 8000 into, so 8000 pi square, because pi into pi is pi square, into 10 power, how much do you have? Minus 7 into minus 4, 10 power minus 11 into 10 power 2. It will be 10 power minus 9. So here 3 zeros will go off. It will be 8 pi square into 10 power minus 6. What value did we calculate? Mutual inductance, no? So 8 pi square microhenry is the answer. Make sense? எதிரா ஆமாம் இல்ல ஒரு சில வாட்டி இப்படி விட்டுறலாம். That depends on the answer given. So it should be 78 point something. 19 points. First one. 78 point something microhenry. I hope you could understand the concept. So if you observe, I didn't apply formula. I didn't directly apply the formula. Rather, I did a part of the derivation and then substituted, so that you will not forget it. I hope it is clear, no? So, 78.96 microhenry. Second, we need to find the induced EMF in the second coil when the current in the primary coil changes from 0 to 5 ampere in 0.02 seconds. So, EMF is equal to M into delta I divided by delta T, or di by dt, whatever you call it, di by dt. So, what is the value of EMF? That's what we need to find. So, since we got the mutual inductance, it is 78.96 into 10 power minus 6. What is the value of delta I? Delta I is 5. I'm not taking the plus or minus, it is 5. The whole divided by 0.02, it is 2 into 10 power minus 2. So it will go to the numerator. So 78.96, I'm approximating it to 80. Okay. So 80 means 2 will cancel this 40 times. 40 into 5 is going to be 20 into 10 power minus 4 volt. 2 into 10 power minus 3 volt. 19.5. Sorry, the 40 into 5 is 200. So it is 20 into 10 power minus 3, or 20 millivolt. Volt. It's 20 millivolt. I think the answer they have written it is in terms of 19 point something, because I approximated 78 to 80. Okay, don't do these kind of approximations. You can calculate it properly. I'm doing it to save time. Okay. Shall I proceed? So those are online. I hope you could get some idea, right? The only thing we didn't solve is we didn't directly substitute the mutual inductance formula and then solve it. That's the only thing we didn't do. I'm assuming that that part you can learn it. Am I right? Okay. Shall I proceed to the next concept?
Yes, sir.
Okay, sir.
Okay. So you can write down energy stored in an inductor. So write down the heading as energy stored in an inductor. Now, the question is, see, we know that E is equal to L into di by dt. What is it? E is equal to L into di divided by dt. But what is our objective in this case? We need to find the energy that is stored in an inductor. So remember one thing, what does L stand for? L stands for self-inductance. See, self-inductance and inductance mean the same. So if they suppose in a problem, they ask you find the inductance of the inductor, they're not asking you the mutual inductance, they're asking you the self-inductance. That should be understood by default. Am I clear with that? Self-inductance and inductance mean the same. Clear? Now, what I need to do is, I need to calculate the energy. Whenever we think of energy, what is that we indirectly calculate? We always calculate the work done, because energy is the capacity to do work. Right? Wherever throughout physics you see, or throughout chemistry, wherever you see energy means you always need to calculate only work, because there is no direct formula for energy at all. Now, the question is, I have E, which is the EMF. But how do I calculate the energy from this? Instead of me calculating energy, that is the work done, the easier thing for me is to calculate the electrical power associated with it. Because power is given by the expression E into I. Are you able to understand this logic? Right. So, what is the value of E? It is L into di by dt into multiplying this I. Can I write it as L into I into di by dt is what is going to be the power? What power is this? It's the electrical power. Correct? Right. But the question is there a power, is there an expression for power which can be written in terms of work done? Yes, you can. Because power is the rate at which work is done. So you can write it as dW divided by dt. Is the sequence clear? So first, what did we start with? We started with the EMF. EMF is equal to L into di by dt. Right. After that, we wrote the expression for electrical power. Electrical power is E into I. So when you write it as E into I, you write it as L into I into di by dt. So what is the value of power? How is power defined as? Rate at which work is done. dt and dt will get cancelled. So if I'm able to calculate the value of work done here, I'll be able to calculate the energy. So I have dW. From this, can I say W is equal to integral of L into I into di by dt? Sorry. L into I into di. Right. So this will be equal to, L can be taken out. What is the integral of I di? It is I square by 2, and this is going to be the amount of work done, and this will be the energy stored. It is half Li square. I told you yesterday, no? Like how for a capacitor we calculate half CV square, here we calculate it as half Li square, but this is the derivation. Then you get it. So this is half Li square. உன்னை பார்த்தா அவனை தான் பார்க்கணும்னு தோணுது. ஏன் உன்னை பார்த்ததுக்கு அப்புறம் அவனை தான் பார்க்கணும்னு தோணுது. கனெக்ஷன் யாருன்னே தெரியலன்றான். Done? Clear with this? Right. So with this, we have almost completed. There is one theoretical concept that is left out, which is called as eddy currents. Okay. I'll show you a video and explain the concept from there. Listen to this. Those are online. Am I clear, guys? Are you able to understand?
Yes, sir.
No doubt now? Okay. So we're going to complete the chapter today. Concentrate. Can someone check if eddy currents is actually there in the new textbook? Deleted. They will delete it here. They will ask it in the they'll ask in the next chapter. Transformer eddy current loss அப்படின்னு என்னன்னு எப்படி புரியும்? என்ன பார்க்கலாம்? காட்டுறேன், அதுக்காக தான் ட்ரை பண்றேன். I'll explain it. Listen. It's a very simple concept, okay? Listen. Don't share. Then officially we have completed the chapter. Huh? Okay. As per CBSE, we are done. So listen. Not this one. Wait. So listen. See, he has a plate in his hand, right? He has a plate in his hand. What he is going to do is he is going to drop it from a certain height. Right? What is obviously going to happen? When you drop it from a certain height, it is going to fall due to whom? If I ask you, explain the science behind it, obviously because of gravity. Right? Is there a way where you can introduce magnetic field in between to make it fall slowly compared to the actual acceleration? Is what we are going to see. Okay? Observe. These are just two really strong magnets that are actually connected right through my hand. I'm going to use copper here. Copper is not magnetic. That's going to be important. So, one concept that we need to recollect is, remember in the previous chapter, when I discussed about the paramagnetic, diamagnetic, and ferromagnetic, I gave you some examples, the 13th point in the table. I gave you a big table, you remember? So in the table, look at the 13th point and tell me under which category does copper belong to? It's a diamagnetic substance, means it is not going to respond to magnetic field. So copper is going to be a diamagnetic substance, whereas steel is going to be ferromagnetic. So the question is, there is a setup, see this, we can actually do it also. There is a small setup that is there where you have a ferromagnetic substance here. So there is a ferromagnetic substance lying at the bottom. I'll see for those who are online, I'm using the cursor, observe. So there is a ferromagnetic substance, right? And there is a magnet that is suspended with the help of a string. Now, if you make that magnet oscillate and pass through the ferromagnetic substance, what do you think will happen? The magnet is oscillating and there is a ferromagnetic substance. If they both come and touch each other, what should happen? They'll get attracted. Whereas if I make suppose instead of the snail being made with steel, had it been made with copper and you keep on top of it, you cannot see any attraction to happen because copper falls under which category? Diamagnetic substance. So it is going to repel the magnetic field. Observe that concept. So he's showing it. Did you observe? He tried to take the copper closer. So observe. Not getting attracted. So here it is going to oscillate. Though it is going to be a ferromagnetic substance, it will oscillate because the distance is more. But if it is taken very close, what will happen? If it is taken close, right? Okay, actually, I'm sorry, there's not a ferromagnetic substance. Here he has actually used copper only. Had it been a ferromagnetic substance, it would have got attracted. But here, copper being itself, what should it do? It should not reciprocate to the magnetic field because it's a diamagnetic substance. But see what is going to happen. So what is our expectation? When you take the magnet away and you release it, you expect it to oscillate, right? And you expect that material to cross the copper plate and then oscillate, right? But see what is going to happen. He actually hits it. Okay, now see what will happen. What happens? It stopped actually. Though gravity was there, it stopped. Did you observe? So this is what is an idea that is used in magnetic braking systems. A few days back, I would have told you about magnetic levitation. Remember that? In a similar way, you talk about the trains, the bullet trains which are getting designed based on the electromagnetic induction. They use magnetic brakes. They don't use the regular brakes, where the friction is actual reason for the stopping. They use magnetism as brakes itself, and there's one such idea that can be borrowed. Did you observe when the magnet was moving, it had a brake, it stopped. And that is happening due to something. I'll tell you what that something is. Now you understood? So from whichever direction you bring, if you have a diamagnetic or a paramagnetic substance, it is going to stop. So this plate itself is divided into two portions. One side it is iron, the other side is copper. Iron is ferromagnetic, it got attracted. Copper is not ferromagnetic. So it's a diamagnetic substance, so it didn't get attracted. Now there is another activity that is being done to demonstrate what exactly will happen if things are going to fail. Okay, he's dropping this copper plate from this height. Now what will happen? It will fall down faster. It's going to fall down faster because of gravity. But you are able to see these two magnets here, the black color ones. So you are able to see these two magnets, right? So for these two magnets, if you observe, if you change the position of them, something can be altered with respect to this activity. Let's see what that is. See, just to show the severity and the dangerous, just to tell how dangerous it is, right? It's just using a carrot as a, meaning if it falls this fast, the object can break into two pieces. So that's the severity of this activity. Okay. So imagine them to be fingers. That's what he's saying. So there are four strong magnets which are moved down. Now look at the risk. You already saw the risk of it if things go wrong. Did you observe? It got slowed down. Vipam, he will keep it secret. So the first one that he dropped did not have any slots on top of it. I'll show you another activity also. You will understand it. It did not have any slots. It's a complete copper plate which was dropped, which got slowed down. But when the slots are there, when some slits are created on top of it, it did not get slowed down. But see, this one has slits. You're able to see those lines. It has slits. Now observe. When it is dropped, at one place it got slowed down, at the other place it did not get. Okay. So I hope you could get some perspective, right? And the last place is moving the magnets. I'll explain the logic. So it works. So based on the position where that magnet is placed, things are changing. Okay. Let's observe the same thing with the help of a paramagnetic substance, that is an aluminum. Okay. So you had this concept been in your textbook. This is the actual diagram that they would have given it. So what you have is you have a strong magnetic poles that are present. One is the north and the south pole. And
currents resulting magnetic breaking that will occur on the pendulum. So what I have here are two magnets.
So he has two magnets, right? So what he has is, he has three aluminum pieces which are treated like a pendulum. Okay, three aluminum pieces which are treated like a pendulum, where one of the aluminum pieces will be completely filled. Like how you have that, what do you say, that currently for putting dosa. You take, no, one will look like that completely filled, and the other one will be with slots, and the third one will look like a comb. So look at them.
Okay, so here
So in the previous case, they used copper, which is a diamagnetic. Now they are using a paramagnetic. So this clearly says that for this concept to be valid, you should not use a ferromagnetic substance. Rather, you should only use a dia or a paramagnetic substance.
It is. So it's not really attracted to that.
So this is the one I told you. Currently. So this is the one with slots, and the third one has a
Slots.
third one has a comb-like structure. Okay, so he is going to pass all these three, right? All these three aluminum plates through this magnetic field. See what will happen. So if it was only gravity, it is going to oscillate like this.
This one through the magnetic field.
It will stop.
You notice how it breaks and stops. Now, if I get to one of the slots,
this 1 minute. Sorry to interrupt. This will also stop, but look at the way how it is going to stop.
slots. We see it. breaks and stops.
Did you observe in the previous case, it was instantaneous stop. It could not go to the other side. As soon as it entered, it got cut off. This time what is happening? It is going inside and then slightly coming back. Whereas, see, observe. What will happen here? It won't stop at all.
Okay.
Okay.
What's happening is that
So I told you, there is a reason why this is happening. All this is happening because of this eddy currents. So what is happening initially when the plate is there, when the plate is trying to enter the magnetic field, what is happening to the magnetic flux associated with that plate? It is changing. When there is a magnetic flux associated with something with a material going to change. So whether you are going to use copper or aluminum, one point to be kept in your mind is irrespective of whether they're paramagnetic or diamagnetic, they both are good conductors of electricity. So when they are good conductors of electricity, because they are metals, when they are good conductors of electricity, what is going to happen? There will be an EMF induced in it. When there is an EMF induced in it, obviously it should have current in it, because the name of the topic is not eddy voltage, it is eddy current. So the currents which are getting generated will actually be in circular loops. That's why this eddy current is also, see, most of the books don't refer it like this. They also call it as Foucault current, F-O-C-A-U-L-T, or they also call it as circular currents. Means that aluminum rod, when it was entering, right, there is a change in flux. Due to the change in flux, EMF got induced, and due to that EMF, there will be small circular currents present in that material, due to which these things got stopped. Okay, so we can actually have a look at it. See.
And the resulting magnet.
So let's assume that there is a magnetic field. Into this magnetic field, what happened? The material entered.
So let's say we're sitting in that gap, just like this.
Okay, so this rod, when it entered, when it was outside, when this plate was outside, what was the flux associated with that? Zero. When it is entering, the flux is increasing. When the flux is increasing, what pole should get generated? Same pole as what we are. So I'm standing this side, I'm looking at the board. Since the board is south pole, since it is receiving the field lines, I'm the north pole. So when the flux is increasing, same pole should get generated. Same pole as what? Same pole as what I am. I am the north pole. So what pole will get generated here? North pole. North pole means what kind of current is supposed to be there? Anti-clockwise or clockwise? Anti-clockwise current. So what will happen is, when this plate is trying to enter, due to the increase in flux, there will be the same pole as what I am getting generated in it, due to which there will be small anti-clockwise currents flowing in it. And those anti-clockwise currents are what are called as eddy currents.
Okay, so as the aluminum pendulum is going in, what we see is that this area, we have increasing magnetic field inside the aluminum into the page. So that we know is going to induce a current, currents are going to start to set up here.
You know the reason now. He has directly drawn it, anti-clockwise current. So these circular currents that are getting generated, they'll not get generated throughout the conductor. Small pieces are everywhere, it will be there. So whichever portion is entering the field will have those currents, and those currents are what are called as eddy currents. So mainly, if you see, it has a lot of real-time applications, especially you go in these what do you say, these theme parks and all, right? You have these roller coasters. So when the roller coaster has a slope and it is going in the upward direction, when you're going down, had the braking system failed, okay, if the braking system fails, imagine what would have happened. You will go in the downward direction so fast that you cannot take that pressure. There is a possibility we'll meet with a very big accident. So when it is going in the downward direction, right, this concept of eddy currents is what is used to slow down the system, not to completely break it. If there is a sudden jerk also, that is also not good for us because of inertia. Okay, so what they will do is whenever it is going in the, let's say from the surface, you are going downward, right? Right. The slope, if it is more inclined vertically, if it is somewhere around 70 degrees or something, but okay, if it goes in that direction, if it is only gravity that is present, right, it will be a very severe accident. So they have to slow it down, for which they use these magnetic braking systems. So they are use of the eddy current. That's how they designed it. For the current to be in a loop, the material should be closed. So material full you will have it. Slots you will have it because it is still closed. But slit open. Understood? So that's the end. Okay. So this is all about eddy currents, and I think all the concepts are over. Right. So this topic, you will see it in the future, in the sense you can open your textbook and see in transformers, there is something called as eddy current loss. And the time is the concept. Basically, when a diamagnetic or a paramagnetic substance is suddenly entering into a magnetic field, it experiences break. And why is it happening? Because of eddy currents. Okay. So any other? Those are online. Are you clear?
Yes, sir.
Yes, sir.
Any question? Any questions, sir? All clear? Tired, huh? Yeah. Okay. We'll wind up. Any questions? Okay, then we'll wind up.
Thank you, sir.
So Monday I'll start with the 7th chapter. Alternating current. Yeah, thank you. Bye.
Thank you, sir.
RLC.